Hi, my name is Leah Cochran, and this is my reflection notebook for Module 2 and 3. So I started with entry 6, content, so the demands of my subject on students. So on the left side, I had how to read, write, speak, and listen like a scientist, and then on the right side, I had the demands. So I came up with challenges and solutions for my particular content area. So some of the challenges that I said were books and other resources were over their heads. It's math-based. It requires more than just memorization. You have to understand. So a lot of my students have a problem with that because they'll look over their notes and they think that they understand, and then when it comes to tests, they'll recognize words, but they're just seeing a word that they know. They don't really understand the process that happens. The material may not seem relevant or important. Technical language. It's a lot of material that we have to cover in the school year. It requires effort outside of the classroom. It requires reading comprehension, and it builds on previous knowledge from middle school. And then I color coded, so each of my challenges has a specific color, and I matched it to a potential solution. So my solutions were that I could chunk material into smaller pieces. I could review basic math when needed, and I could differentiate. My plan next year is more of a flipped classroom, so I could have my lectures recorded, and the people who are comfortable with the material could listen to that lecture, and I could have the other half who maybe need a little help with math or whatever we're going over. I could break them into small groups while the other part of my class is listening to lectures. I'm excited about that. Find experiments and data that are current and students are able to relate to. So try as hard as I can to do find something that they'll actually care about. And if I have to do graphing or talk about something that's really kind of boring, maybe make it student relatable some way. Encourage outside the box thinking that will keep students interested and engaged. I know that I like to personalize my stuff and really make them take ownership. I really like doing video recording assignments for my students, and they really get into it, and it makes them think about it more. And then acknowledge previous learning and use this to assess strengths and weaknesses. My next entry, which is number 7, is Howard Gardner's Multiple Intelligences. So on one side, I have the intelligence strength, and then on the other side are my ideas for including this into the classroom. So I wrote them all down, and I didn't say on the last part my first entry, but I teach biology and marine science, so all these are biology and marine science related. For verbal linguistic students, I could have the students create a way to remember a process like an acronym. So for phases of mitosis are prophase, metaphase, anaphase, telophase, so they could come up with their own way to remember PMAT, which is the acronym for that process. And they could do that with buddies, and then we could say them to the whole class, and then maybe vote on the favorite one. And that sounds like something my kids would get into, especially the sharing part. So logical mathematical, there are lots of logic puzzles available for science teachers. One of them that I found is earthquake mix-up, where you use blood types of babies, and there's a natural disaster in this activity. It's an earthquake, but you have to match the babies to the parents based on their blood type, and it's kind of, it's not kind of, it is a puzzle. For visual spatial, in the beginning of the year, we go over safety procedures, and we talk about where all the safety equipment is, so my students could do something like create a map with all the safety features that we have, like the fire extinguisher and the safety shower and the sharps box, and take note of anything like obstructions like desks or where the lab benches are. And that would really be geared towards visual spatial people. Musical show videos like Lab Safety Song and Chemistry Elements Song, or students could create songs or rhythmic chants for complex processes. So that'd be a really good buddy work thing too, maybe a bell work thing. Come up with a way to remember the process of photosynthesis or the formula for photosynthesis, and we could discuss it and then use the best one. We could vote on the best one and use the best one, and we could chant that every day. Body kinesthetic. I could use an app. There's one called Stop Motion Maker, and you can make a Breck film, which is basically the same type of filming they use for claymation. So a complex process like transcription or translation. We could use everyday objects or clay if it were an advanced class, an honors biology class, and they can make their own video of the process of transcription and translation. And then students can present the film, and we could discuss, were there any parts that you thought were really clever or that made a lot of sense to you, or did you spot an error and how could we fix it? Interpersonal. So Skype, really cool. I just found this probably a week ago. Skype offers, well, a week ago because that's when I did this, experts in subject area to speak in classrooms, and students can interview professionals from around the world. It is so cool. You just schedule a time with all different types of people, and they'll talk to your whole class real time. And there's things like virtual field trips you can take too, and they have them backlogged so you can watch them just as a video, or you can actually have your class go on a dive or something. It is probably the coolest thing I've ever seen. Intrapersonal, interactive or reflection notebooks, love that idea. I really want to bring that into my classroom next year. Also something like a debate over a controversial topic, which in science there's many. GMOs, are they good for you? Are they bad for you? How do you know? Support this with evidence. Or things like cloning. Should we do it or not, and why? What are the benefits? What are the drawbacks? The last one is naturalistic. So the very beginning of the year, the first chapter we talk about is what is life, and use evidence to support if something is living or non-living. And we could go outside and walk around and take note or take samples of living and non-living and use our evidence or discuss, maybe kind of front-loading that before I give them what constitutes life. Also, there's an app called Goose Chase that is a scavenger hunt app where students take pictures of objects they find, and the class as a whole votes on who has the best picture. So I could do something like that in the beginning of the year or with a couple other chapters, and I could use that to help with vocabulary, especially living versus non-living. That would be another good place to put it. All right, the next one is Bloom's Pyramid. So I had past teaching experience and then what I could do in the future to utilize this in my classroom. And I'm not going to lie, I was pretty excited because I had scrapbook paper that had little flower blooms all over it. So I got to use that there. Okay, my past teaching, I have not seen this pyramid before. I kind of naturally got that style of learning just from being in the classroom and being a teacher. So I actually had a question about this one. Was in the past I've used this, but not every step has been deliberate or sequential, and I've kind of chunked steps together. So is that wrong? Do you have to go through each one separately, or can you take the evaluating step and put it in with the understanding step? I don't know. How much time do I have left? So in the past I've used Create. They modeled mitosis. They've created ocean zone diagrams. So once I taught the zones of the ocean, they would kind of they would put organisms in a specific place, and they would tell me why they belonged in that zone. So in the future, what I can do to remember is card sorts, where I group information into categories like mitosis versus meiosis. That also goes into the understand category. Analyzing and applying. There's a Venus flytrap lab that I found on education.com, and it talks about, or you investigate the roles that enzymes play in digestion. so cool. And it also has applications to biotechnology, so it has a section where you could take those proteins and lay them on a gel electrophoresis, and that's one of my chapters that I have to go over. So this is more of like a long-term lab, but that is definitely applying analyzation or analysis. And the last two, evaluate and create purposeful mistakes. So I've actually done this one in my classroom already. I created a chart of mitosis and meiosis and all of the steps, but I put intentional mistakes in there, and I didn't tell them how many mistakes there were. I handed it out in the beginning of class, and I said, grab a red pen, and you find the mistakes, and you tell me when you think you're done. And so it really kept them occupied, and I only did it once that year, but the one time that I did it, they were very engaged, and everyone was looking at a part. Oh no, I think that this is a problem, or I think that this is a mistake. Well, why do you think that? And it caused a lot of discussion between the two, and it was fun to go over it at the end and see who is the winner. It kind of lets them be the teacher. Another idea is that to do part of the gradual release of responsibility is the student can create their own purposeful mistakes. So they could create mitosis and meiosis, and they put purposeful mistakes. So in order to understand where a mistake would be, they would have to understand where that, how the process actually worked. And then they could trade with Buddy and see if they can find each other's errors and then have a discussion to follow. My next entry was the depth of knowledge level. So I had to look at this chart and compare it to Bloom's pyramid, and then tell why it was important to use. So this is what I have. It's so funny peering over the camera like that. Okay, so I wrote down the DOK chart is similar to Bloom's pyramid in several ways. There are levels through which a student will progress to enhance learning. Both graphics start with the same base level, which is recalling or remembering. And additionally, both models are important to achieve the highest level of knowledge. Following the DOK and Bloom's learning framework will ensure that students don't remain in the shallow end of the knowledge pool. So basically these are really important to follow or use or have some type of similar framework in the classroom, because it ensures that your students aren't just staying on that very base, memorizing facts and then regurgitating them for an exam. Next entry was the gradual release of responsibility. So I had to brainstorm how to use this in my classroom. So the I do it part, and these are kind of random and all over the place. PowerPoint lectures, the I do it part. PowerPoint lectures, modeling, laboratory and behavior, modeling laboratory procedures, microscopes, anatomy and use, demonstrations. We do it, card sorts, office mix projects, demonstrations, microscope, anatomy, and use. So I could start off by doing an office mix and show them how I would do mine, and they could be kind of working on theirs as they're watching me. You do it together, so another card sorts. I love card sorts. I think they're awesome. I do them over and over and over again, and then when I feel comfortable that my students understand, we glue them onto a graphic organizer so they can use it to study, and it's way better than taking notes. For some of my students, I taught lower level inclusion classes, and some of the children weren't the greatest writers, so it really helped them just having something that they didn't have to write. Worksheets, puzzles, projects, office mix, Padlet, and scavenger hunts. And then the you do it alone, card sorts, worksheets, projects, office mix, and quizzes. So those are a bunch of different things that I could do. Okay, the next part